All right, welcome back once again. Now what we'll be doing, we'll be discussing our abstract data type. What exactly is an abstract data type? And then we'll jump directly to our circular linked list. If you remember from our last lecture, from last week, we talked about in chapter 16, the author talks about different types of linked lists. Talks about unsorted linked list or unordered linked list, ordered linked lists, doubly linked list, and circular linked list. For my demo, I have chosen to show you a circular linked list. A circular linked list is a linked list which all the nodes are connected to each other. So this first node, assuming this is our first node, I can tell it's a first node because my first pointer is pointing over there. So, and I'm going to leave this first pointer there just in case I need to find out what is the first data type in my first node of my linked list. Then this link or this link is pointing towards the second node, that's node number 2. This second node is pointing towards third node. And this third node, notice that it goes back and connects with the first node. So it becomes like a circular linked list. If I do not have this last link between the third and the first one, it will be probably, in this case, ordered linked list because the data is ordered. 5, 7, 18. It is in ordered form. It's a sorted or ascending ordered data. Now, if you do not really care, you say whatever the data comes in, I'm going to put the data in the last node. That will be unordered linked list. That is the easier one, but the problem with that would be that when you have a lot of data, it's harder to find it. Now, for assignment 1, what I would like you to do, in our demo, we are taking whole numbers or integers. Maybe you as a developer, while you're developing your first assignment, can give that option to the user so user can choose to provide you whole numbers, single characters, or strings. So if the user says, I would like to create a linked list of string data type, then the string data will be saved in your linked list, circular linked list. If the user decides to choose character data type, then you'll be adding characters in your linked list. So that will be our assignment 1, and I'll be discussing in more detail once we get to our Moodle website page. Now, another important thing I would like to highlight is in abstract data type is that in abstract data type, you can actually create an abstract type of class, which means if I show you right here, so here's my template, and I'm saying I'm going to create a class of type, or type is the name of my class. Type assigned by me will be a class type of object I'm going to create, and that's a template. What it means is, at the time of the creation of my template, I do not know what type of data will be available, what type of data will be given. So I can actually, if I create as a template, I should be able to create any kind of data. For example, if you notice here, if I say type info, now this particular control data structure allows you to create integers, whole numbers such as integers, doubles, characters, strings, or any other type of data. If I make it integer from last week, if you remember, we had integer here. This is what we have last week. So instead of type, we had int info. So if I create as integer, then I am actually restricted to create only whole numbers. But I do not want to create only whole numbers based on how my user want to access. So user probably wants to provide you characters or strings or decimal places. In that way, I should be creating this as a template. So when I create as a template of type data type, which means any kind of data can be provided to this particular data structure. Okay? So shall I go in more detail, or you guys are okay with this? So why I'm changing from int to type, I'm changing this into type because I would like to make it as a template of this type. And you can call it anything you like. In some cases, I'll show you just T or any other keyword you want to use over here. You can call it T here, and this will be called T info. Letter T info. It means that this info is of any type based on how I call it during the execution of my program. Okay? So the node type, remember node type last time we had like this, node type, and we had simply link or list. Or we can call it link. I think it's better we call it link. So there's no confusion between link and list. So let's call it link. Let's call it link here as well. So that's my link. That link refers to this part here. That's your link right there. So maybe I can bring the camera closer. So this will be the link. These are the links right there. And this is where the info will reside. So this in this on this whiteboard currently we have whole numbers, but because it's of type, it can be strings or characters. That will be your assignment 1 as well. That how you actually handle your program. That in your circular linked list you can have different types of data, not only whole numbers but characters or strings or maybe other types of data can be added. Okay, so that will be your data structure. So we made a couple of changes here. We added a template from last week. We didn't have the template before. And we also changed our info type from integer to type. So any kind of data can be handled. Okay, so that is a template. Once you have declared your template, once you have the template in place, then right underneath you can create a class. And you can say class linked list, name of your class. In my case, it's called circular linked list. So if that's the kind of class you want to create. Now, different authors prefer different things. I personally prefer the data variables are declared and highlighted first. So my data variables are provided first. But in the textbook, you might find the data variables either private or protected, they are provided at the end of the class. So I'm going to show you both ways. I personally like the data is right there because that's the first thing you as a developer want to see. What data is there? What variables are there? How do you handle the data in this particular program? So data variables I like to highlight here first. So I have a simple integer count. I just want to see how many nodes are created. So that count is just going to count how many nodes are created at the time of the creation of that object. So it's just going to say plus plus count. Every time new node is added, it's going to increment the count to 1 and 2 and 3. I also have a variable here of pointer type. It's a pointer variable. I can tell it's a pointer by looking at this asterisk. It's called first. I would like to have this pointer so I can highlight, I can show where exactly the starting point of the linked list is. So I want to assign this pointer to the first node. So if I don't assign to the first node, there's no way for me to circle through my linked list. I'll forget where exactly the linked list begins and where exactly it ends. Similarly, I have a pointer of again the same type. Now remember from last week we can if you remember, we didn't have to use the type here, but because we are making it abstract data type more generic, so we can handle any kind of data. That's why we have a type here. But I have a pointer variable, so I can actually point towards the last node. So if I want to start printing, I can start from the first. I can go to the next, and I can go through this. I can cycle through this one, and it's called traversal. I can traverse through the entire linked list, so I can figure it out where the last one is. So I can stop. If I find the last one, I can stop. So that's the reason you want to have at least 2 pointers, if not more. And in our example, in our demo file, we'll probably see a few more pointers as well, especially when it comes to insertion, deletion, and so on and so forth. especially when it comes to some of the other methods, you must have some of the temporary pointers as well. Hold on to the temporary pointer, point in a certain node so we can delete it and remove it from the memory. So that's what we have as a protected data type. Can I declare this as a private data type in this example? Absolutely. So this is declared as protected, so the derived classes can access this data. If we have additional derived classes, they can access the data. If that's not the need I have, then I can make it private. All right, so then we'll see in our demo file, which will be our next step, that how many constructors I have. So I like to see my constructors first. Again, that's your programming style. Some people leave the constructor at the end of all the methods. I like to have the constructors on the top of my, where my class is declaring all the methods. I also want to highlight one more thing before I move on, that the declaration part in object-oriented programming is typically separate from implementation part. Let me clarify this one again. So when you declare something, you say, I intend to declare this method. So you only have the signature or the header of the method, not the body of the method. The body of the method will be separate from the header of the method in a larger system. But here, just to keep it simple so we can see everything in one place, I actually put everything in together. But in the book, you might find declaration is slightly separate and the implementation is separate. Implementation means the body of each one of those methods. And it's really, really easy that where exactly I can put the header file and where exactly I can put the CPP or source files. So we'll start with one source file. Hopefully by next week, we'll be able to separate the header files and source files. But in this first project, if you're not comfortable, it's okay if you can submit just one CPP file. But for project number 2, I'll be asking you to submit all the header and source files as well. For the first project, we are okay. Okay, let's take a break.